Hey everyone, I'm Dr. Sandeep and we are going to discuss the Neet question paper from question number 26 to 50 for the physics section. So question number 26, let's just read the question once. A wheel of a bullock cart is rolling on a level road as shown in the figure. So you can see this. If its linear speed is v in the direction shown, which one of the following options is correct? So you can see that point P and point Q are the highest and the lowest point, and we can look into the correct option. The correct option would be number 4, where the point P moves faster than point Q. Now this happens because, if you can look into the figure, Q is the instantaneous center of rotation, so that at the point at which the body has zero velocity. Now all the other points of the body rotate around it in a circular field. So Q remains 0 during rolling, and the P will be given a velocity of v plus r omega because there is a rotational motion involved as well. As a result, we can say that P is moving faster than Q. Now the difficulty level for this is level 2, level 1 being easy, level 2 being medium, and level 3 being the most difficult one. Let's go to question number 27. It says a particle moving with a uniform speed in a circular path maintains. Now, whenever a body is moving in a circular path, please remember, if you want to find out the velocity at any point, you have to draw a tangent. So the velocity at each and every point keeps on changing. So if the velocity changes at every point, that means the acceleration should also change at every point. Hence, the right option for question number 27 is number 2, varying velocity and varying acceleration. It's uniform speed, but it's moving in a circular motion. So that was difficulty level 1. It was an easy question. Question number 28 says a thin flat circular disc of radius 4.5 centimeter is placed gently over the surface of water. If the surface tension of water is 0.07 Newton per meter, then the excess force required to take it away from the surface is what? Now, the first thing is the radius is given in 4.5 centimeters. So let's just convert it into meters. So it would be 0.045 meter. The tension is already provided. Now, if you want to find out the excess force, you can directly use the formula of force is equal to circumference into tension. Now, it's a circular disc. So the circumference would be 2 pi r into tension. So it is 2 into 3.14 into r. It can be converted into meters by multiplying with 10 to the power minus 3 into 0.07. So if you do the calculation, your answer would be 1.98 into 10 to the power minus 3 Newton, which stands to be 1.98 millinewton. Well, it's a medium level question because you need to know the formula and then only you can do your calculation. So the correct option would be option number 3. Next we have question number 29, and just let's look at it. It has got a direct formula to it. In a uniform magnetic field of 0.049 Tesla, a magnetic needle performs 20 complete oscillation in 5 seconds. So you can easily find out what's the time period. It's 20 oscillation in 5 seconds. It means it will be 1/4 of a second for one oscillation, so that's the time period. The moment of inertia is given, and the magnitude of the magnetic moment you need to calculate in terms of 10 to the power minus 5. So here we are going to use the direct formula of time period for our needle placed in a magnetic field. T is equal to 2 pi root over I by mb. You can change the formula and write it like this. Okay, T is equal to I by 4. Now if you look into this, you can do your simplifications here. 2 pi root over I by mb. I'm interested to find out m. Okay, m is your magnetic moment of the needle, which is given to be x into 10 to the power minus 5. So you can replace all the values. The time period would be nothing but 5 divided by 20, and then pi, I, the moment of inertia, is given, and the magnetic field B is also provided. So once you replace all the values, t is equal to I by 4 and all the other values, you can solve them, and the final answer that you get is I by 16 is equal to 4 pi square into 20 by x, or you can find out the unknown x as 1280 pi square. So the correct option would be option number 2. Now it's obviously a formula that you need to know, and it's not, something which you learn on a daily basis. This formula, you have to know it directly. So that's why we can put it in the difficulty level 3. Let's look into the next question, question number 30. We have got two bodies A and B of the same mass undergo complete inelastic one-dimensional collision. So it's a problem from collision. The body A moves with velocity v1 while body B is at rest before collision. So it is at rest, body A moves. The velocity of the system after collision is v2. The ratio of v1 by v2 is. So, it is a completely inelastic collision. It simply means that the two bodies will stick together after collision. So they will move with a common velocity, let's say capital V, after collision. So in such cases, the velocity is given, that means the V, the final velocity with which the two body moves after collision, would be m1 u1, where m1 is the mass of the first body, u1 is the velocity of the first body. The second body is at rest, so that's u2, which is 0, divided by m1 plus m2. Now both the masses are same mass, so it is m1 plus m2, it will become 2m, and it is said that the velocity after the collision is v2, so we can write it down as v2 is equal to v1 by 2m. So mm gets cancelled, v2 is equal to v1 by 2, so v1 by v2 is equal to 2 by 1, so the ratio is 2 is to 1. So the correct option is number 4, 2 is to 1. That was an easy question based on collision, so we have put it in difficulty level 1. The next question is from the chapter of simple harmonic motion of class 11, and they have given you the equation. This is the displacement equation, we know, and we can write down the standard equation and compare and find out different parameters. So you can look at in the question, they have given the equation here, represents the motion of a particle executing simple harmonic motion. By that we mean, that the acceleration is proportional to displacement. That's the definition of simple harmonic motion. What will be the amplitude and time period of motion? Now whatever is the coefficient of the sine term would be the amplitude, or it's 5, so obviously that's 5 meter. So you can see that it's in meter, so the option 1 and option 3 automatically cancels out. It can be either option 2 or it can be option 4. Now we have to find out what is the time period. So time period means time for one oscillation. Now if you compare it with the general equation, this is my general equation, a sine omega t plus phi, and if you look here, this is omega is equal to pi. You can see omega is equal to pi, but what is omega? That is angular velocity, as given as 2 pi divided by t, or it's 2 pi by t must be equal to pi if we compare with this. So pi will get cancelled, t would be 2 seconds. So the correct option is number 4, 5 meter and 2 seconds. Let's go to the next question, which is theoretical. The quantities which have the same dimension as those of solid angle are. Now solid angle from the first chapter of units and dimension in class 11, it's having a unit of steradian, and it's a supplementary unit, so it does not have any dimension, so it is dimensionless. So that means in the option I have to check which are the quantities that does not have any dimension. So let's look into the solution for this. Now if you check here, strain, okay, stress by strain, as in Hooke's law, strain is change in dimension by original dimension. So that means strain does not have any unit, so its dimension would be m0, l0, t0, and of course solid angle also has a dimension m0, l0, t0 because it's a dimensionless quantity. Apart from that, arc. Now arc, if you measure, it will have the dimension of length, so it cannot be the answer. Speed has a dimension. Stress is force by area, has a dimension. But angle and strain does not have any dimension. Angle is again a supplementary unit, so it does not have any dimension. So stress and angle, again stress has got dimension. So the answer is quite simple. It's number 3. It's a very simple question from the first unit, so you can take it to be at the difficulty level 1. So the answer is stress and angle, strain and angle, sorry. Let's go to the next question, question 33. A thin spherical shell is charged by some source. The potential difference between the 2 points C and P is shown in the figure. So the first thing, it's a spherical shell, and if there are charges on the shell, there is no potential inside it. So the potential at C is 0. we have to find out what is the potential at P, and then obviously you can find out the difference, Vc being 0 and Vp being the value that you need to calculate. Now for a potential spherical shell, the potential on the surface is q by 4 pi epsilon naught r, where r is the radius, and we have to find out the potential. We should know the charge. It's already given that the charge is 1 microcoulomb. You can see, check from the figure, convert it to coulomb. Radius is 3 centimeter. Let's convert it into meter. So we can put in the values here, and 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Put the values, do the calculation. Your answer should be 3 into 10 to the power 5. So 3 into 10 to the power 5 minus 0 will remain as 3 into 10 to the power 5. So your correct option would be 3, that is 3 into 10 to the power 5. This is from the unit of chapter of electric potential, and it is for a charged spherical shell. Again, this is a very simple question, so we'll put it in difficulty level 1. Question number 34. A bob is whirled in a horizontal plane by means of a string with an initial speed of omega rpm, that's rotation per minute, and the tension in the string is T. Now if the speed becomes 2 omega while keeping the same radius, the tension in the string becomes. Now you have to find out what is the tension in the string, and tension is a form of force, and force formula for tension can be written as mr omega square, where omega is the angular velocity. So if we consider the first case, T1 is equal to mr omega 1 square. Now both the cases it's omega, so let's take it as omega. So we replaced omega by omega, 1 by omega. So that's the first case. In the second case, what happens is that the speed becomes twice, so it becomes 2 omega. So in place of omega, we're going to put 2 omega and then square it. So we get mr 4 omega square. Now we can divide 2 by 1, and we can get it to be T2 divided by T is equal to 4 divided by 1. Now in that case, T2 is equal to 4 times the tension. So what was T? The tension T was when the speed was omega, and T2 is the new tension that we need to calculate when the speed increases to twice omega. So the correct option is number 4, that is 4T. So it's quite obvious, if you are rotating something and if you're increasing the speed, definitely the tension will increase. Let's move on to the next question. Question number 35. It says a wire of length L and resistance 100 ohm. So the entire length wire has a resistance 100 ohm, is divided into 10 equal parts. So that means one part will have 100 by 10, that means 10 ohm of resistance that we have calculated here. The first 5 parts are connected in series. So if resistances are connected in series, the total will be just the addition of them. For the first part it is 50 ohm, while the next 5 parts are connected in parallel. So you can take the reciprocal and add them up, and then take the reciprocal, you are going to get 2 ohm. So for series it's 50 ohm, for parallel it's 2 ohm. The question is, the two combination are again connected in series. So this parallel and this series are connected now in series. So that means 50 plus 2, that is 52 ohm would be the total resistance. So we can do the answer as we are going along with the question. So the correct answer would be 52 ohm, that is option number 4. This is actually a simple question, but still you need to know what is the parallel combination and the series combination. Next question, question number 36, comes from Charles' law. And if you look into the ideal gas equation, PV is equal to nRT. Let's just remember this and look into the question. The following graph represents the TV graph, that means temperature versus volume curve of an ideal gas. So PV is equal to RT, nRT. At 3 pressures, P1, P2 and P3, compared with those of Charles' law, represented a dotted line. So you can see that these are the values that have been given. You have to find out the relation between the pressure P1, P2 and P3. So it's quite obvious, if the volume is more, the pressure is less. If the pressure, volume is less, the pressure would definitely be more. So if you squeeze in something, the volume reduces but the pressure increases. So that means volume and pressure are inversely proportional. If you check from the graph and look here, this has got maximum volume P3, P2 is less than that, P1 is less than that. So in volume it would be V3 is greater than V2 is greater than V1. So in pressure it will be just the opposite. P1 would be greater than P2 would be greater than P3. So the correct option would be number 2. If you know Charles' law, you should be able to solve this directly. The next question is from the chapter of electromagnetic induction. Let's just look into the statement, and it's quite simple. So you have a parallel plate capacitor and it is charged by connecting it with a battery through a resistor. So if I is the current in the circuit, then in the gap between the plates, what happens is, first thing you should know what is the formula for displacement current, because the first statement is displacement current of magnitude equal to I flows through in a direction opposite to that of I. So displacement current is something which is because of the electric field between the two plates, and the relation is epsilon d phi by dt. Okay, so if what happens is that the displacement current will only be generated due to the change in current, but here it says that the capacitor is fully charged, okay, by connecting it with a battery. So there is in fact no change in current. So there is no change in current. As a result, if there is no change in current, I cannot get any kind of displacement current here. So as a result, the displacement current must be zero. So you can omit all the options. The correct option would be number 3. There is no current. Let's look into question number 38. Again, a theoretical question about electromagnetic waves. The property which is not of an electromagnetic wave traveling in free space. So this travel with a speed 1 by root over 4 mu naught epsilon naught. That's correct. In fact, if you put the value of free magnetic permeability and permittivity values and calculate it, you are going to get the answer as 3 into 10 to the power 8 meter per second. So this is the correct statement. They originate from charge moving with uniform speed. Okay, now this is something which is actually not correct, because they are saying which is not of electromagnetic waves. So what happens is electromagnetic waves will be generated from charges which are actually moving with some kind of acceleration. Now it is uniform speed, it does not generate any kind of electromagnetic wave. So it has to accelerate, so it cannot be uniform speed. If the speed is uniform, the acceleration is zero, hence this is the right option. That means this is the wrong statement. They are transverse. Yes, electromagnetic waves consider light waves, visible light, UV visible, and everything are in transverse in nature, where the particle will vibrate in a medium perpendicular to the propagation of the wave. The energy density in electric field is equal to the energy density in a magnetic field. This option is also true. So it's a quite a straightforward question. So that's why we have put it in difficulty level 1. Let's look into question number 39. Choose the correct circuit which can achieve the bridge balance. So in case of bridge balance, it means that there would be no current that will flow through the galvanometer G. So it's basically coming under the Wheatstone bridge principle. Okay, and if you look here, this is a diode where we are basically connecting the negative terminal to the positive terminal, and this positive terminal is obviously connected to the negative terminal. So that means this diode is in reverse bias condition. Now if it is in the reverse bias condition, it does not allow any current to flow through it. Okay, and that's why 15 and 5, it will act as a balanced state in this Wheatstone bridge circuit. So that's why we can consider that option 2 is the right answer. Let's go to the next question, again theoretical. If the plates of a parallel plate capacitor connected to a battery are moved close to each other. So the capacitance of a parallel plate capacitor, I guess all of you remember this, very simple, epsilon naught A divided by D. So that means if I increase the distance, the capacitance will reduce, but here it says that it is moving close to each other. So that means D is moving in, that means the capacitance will increase. Now keeping that in mind, let's read the statement. The charge stored in it increases. So charge is equal to C into V, we know, and potential will remain constant as the battery is connected. So we can say that the charge will remain depend on capacitance and voltage, but voltage remain constant. Capacitance will increase if the distance is reduced, so as a result the charge should increase. So this statement is true. The energy stored in it decreases. Now energy does not decrease, in fact it increases, because it is half CV square. Okay, and C increases, so the energy should increase. So this is a wrong statement. You have to see which is the appropriate answer. So that means you have to choose the correct. So A option is correct. You can see A here, and A here. So out of these 3, we should have the right option. Let's go to the next part. Its capacitance increases. So obviously the distance decreases, so the capacitance should increase from this particular formula. So this statement is correct. So A and C are correct. Let's look into this. So here A and C is here. Here also A and C is here. But we know that B is not correct. So obviously the correct option should be 4. But anyway, let's look into the last option. the ratio of charge to its potential remains the same. Okay, now this is again something which might not be true, because the charge and the potential will differ. The product of charge and voltage increases, that's again true. Charge and voltage, you multiply it, and q is equal to cv, so it will be cv square. V remains constant, c will change, increase, so it should also increase. So that means the correct option are A, C and E. So number 4 is the right answer. Let's go to the next question. Question number 41, again from units and dimension. Till now we have encountered two questions from this unit. The first one. Now we have got a force defined by F is equal to alpha t square plus beta t, which acts on a particle at a given time. The factor which is dimensionless if A and B are constant is. So let's just look into the option dimensional analysis. So we have been given F is equal to alpha t square plus beta t. Now using the principle of homogeneity, this should have the dimension of F, this should also have the dimension of F. That means these two must have equal dimensions, right? So that means these two must have equal dimensions. That means T must be equal to beta by A. If we just equate them, T is equal to beta by A. Now put T is equal to beta by A in all the options. If you put T beta by A, then what happens is, sorry, beta by alpha, then what happens, this becomes beta square. So that's something which may not be dimensionless. Here again it cannot be. If you look into number 4, this might work, because if you put T is equal to beta by alpha, okay, you see that this beta and this alpha will get cancelled, and this will actually become a dimensionless quantity. So that way we can say that option 4 is correct. It's a level 2 difficulty, because you need to know what is the principle of homogeneity. Let's go for the next question. Question number 42. It says that Young's modulus of a metallic bar is given, and the coefficient of linear thermal expansion is given. So you need to know two additional concepts here. One, you should know from Young's modulus, that means elasticity, and the other one you should know the coefficient of linear expansion formula. And we have got 1 meter, and the area of cross section is heated from a temperature to 100 degrees centigrade, from 0 to 100, without expansion or bending. The compressive force developed in it is. So let's take it simple. Let's just first find out what is the formula for Young's modulus. That's stress by strain. Stress is force by area, and strain is change in length by original length. And our aim is to find out what is the force. So that means I need to find out what is this F. So if you adjust your formula, you can take this crosswise. What are the unknowns? Let's see. Y I already know is given. Young's modulus is provided. I is L is the length that is given. A is the area that is again provided, 10 to the power minus 3, and then delta L. Now delta L is the change in length. Now this change in length will be temperature dependent, so we should know the coefficient of linear expansion. So that's why the formula for it is delta L is equal to L naught alpha delta T, where delta T is the change in temperature from 0 to 100, so that's 100. Even if you convert it to Kelvin, it will remain as 100, because change of unit does not change the change in difference. And alpha is given to be 10 to the power minus 5. You multiply all these, you get delta L is 10 to the power minus 3. Replace the values and do your calculations. Your answer should be 50 into 10 to the power 3 Newton. You can look into this after you pause the video. So this one is a concept which is a mixture of two units, mechanical properties of solids and thermal properties of matter, and that's a very interesting question, and that's why we have put it in difficulty level 3. The next question is on optics, and it talks about the re-optics. A small telescope has an objective of focal length 140 centimeter and an eyepiece of focal length 5 centimeter. So you've been provided with the focal length of objective and eyepiece. You have to find out the magnifying power. The formula is quite straightforward. It is focal length of the objective by focal length of the eyepiece, that is 140 by 5, which is equal to 28. So it's a straightforward answer. Should not take more than 30 seconds to solve this. Straightforward, hence it is difficulty level 1. Go for the next question, number 44. An iron bar of length L has a magnetic moment M. It is bent in the middle of its length such that the two arms make an angle 60 degrees with each other. The magnetic moment of the new magnet is. So it's an iron bar of length L, and it has got a magnetic moment. Now if we bend it, and that means we are talking about two lengths now, which are having a magnetic moment, let's say M1 and M2. When you actually break it into two, the magnetic moment will also be half. That means M by 2 and M by 2 for each, and each of them are making an angle of 60 degrees. So for this kind of calculation, we have got the direct formula from the chapter of magnetism, m is equal to m root over m1 square plus m2 square plus 2 m1 m2 cos of theta. So that means this would be equal to root of, you can take m1, it will become m by 2. As I said, the magnetic moment is also half. M2 would also be m by 2, and theta is equal to 60 degree, and in place of m1 and m2 you put m by 2, so that it will be m square by 4, m square by 4 multiplied by 2, and then you can do your calculations, and this would be m divided by 2. Okay, so this answer would be m by 2. That's option number 4. Let's go to question number 45. That is actually from alternating current chapter and talks about an LCR circuit. So you can see in an LCR circuit there is only a capacitance, there is no inductance, there is no resistance. A 10 microfarad capacitor is connected to a 210 volt 50 hertz source as shown in the figure. The peak current in the circuit is nearly. So you have to find out the peak current. So you know there are two currents, RMS current and peak current is equal to I divided by root 2. Now no inductor and resistor is present, so we can easily find out what is my current. Now for current you have to use the Ohm's law. That means uh, you can compare it here. So the impedance is given by root over of 0 minus xc whole square, or the impedance is just the capacitive reactance. And what is Z? Z is the impedance. So impedance is equal to V by I. That means the total voltage divided by the total current. Our aim is to find out what is I. If I find out I can put here I and then find out what is my peak current I naught. So for finding out I, what we do is we use this formula V by I is equal to, now this is XC, okay, XC is the inductive reactance, okay, so it will be 1 divided by 2 pi nu C, where nu is the frequency. So if you simplify this, you can pause the video and look into the calculation. You'll get the current to be 0.21 pi amperes. So I naught would be equal to root over and 2. There is a printing mistake here. Divided by root 2. Okay, sorry. This is I is equal to this. So I naught would be, if you calculate it, it should be 0.93 ampere. So the correct answer for this is 0.93 amps. Okay, let's move into the next question. Two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively. Those two are first connected in series and then in parallel to a fixed power source. The ratio of the power output for these two cases are. So just like resistors connected in series and parallel, if we're talking about two power sources connected in series and parallel, we can have the relation as this. When they are in series, we need to take the reciprocal of these powers and add them up and then take the reciprocal. So that means the series connection, the powers would be P1 P2 by P1 plus P2. The powers are given to be 1 kilowatt and 2 kilowatt, so you can directly take it to be 1 into 2 by 1 plus 2, that is 2 by 3 kilowatt. Now when they are connected in parallel, the powers are added, so that means P1 plus P2, which is equal to 3 kilowatt. And now I can easily find out the ratio of P series by P parallel, so which is equal to 2 is to 9. So the right answer would be option number 4, 2 is to 9. This is from current electricity chapter. Let's go to the next question, question number 47. Here the velocity time graph is given and you are supposed to find out the acceleration and time graph, but that's quite simple. You see from 0 to this particular point there is no velocity, that means the acceleration would be 0. Acceleration is 0 here, 0 here, 0 here, 0 here, so that's fine, correct. First part correct for all. Let's look into the next part. Here you can see that the velocity is increasing at a constant rate. So if the velocity is increasing at a constant rate, the acceleration will remain constant, so it remains constant here and it will be positive because it is having a positive slope, so it is positive and it is increasing at a constant rate. This is negative, so this option goes out. This also won't be true because the acceleration will remain constant and not increase at a constant rate. This is also not true. In fact, this is also not true. So straight away up to this point, if we analyze, we can see which is the correct answer. Let's explain the rest of the part. You can see that if we consider this part, the velocity is constant. If the velocity is constant, then the acceleration would be 0, so this part is 0. Here the slope is negative, the velocity is reducing, that means it is retardation, so the acceleration would be negative. For this, the correct option would be nothing but 47(1). Okay, so that's actually simple if you just look into the kinematics of things here. Okay, let's go into option number 48 or question number 48. The question number 48 says that if the mass of a bob in a simple pendulum is increased to thrice its original mass and its length is made to half its original length, then the new time period of oscillation is x by 2 times its original time period. Then the value of x is what? Now, you have to talk about the relation between time, mass, and length. Now, the time period for a simple pendulum is in fact independent of mass. It just depends on the length, because we know t is equal to 2 pi root over L by g. So, t is proportional to root over of L. So that means T1 by T2 must be equal to root over of L1 divided by root over of L2. T1, let's keep it as T1. For T2, in the second case, it is given that the period is x by 2 times the original time. So if T1 is the original time, it will be T1 into x by 2. And now if I take the ratio, I'm going to get it as, 2 by x is equal to root 2, because T1 and T1 gets cancelled here, L1 and L1 gets cancelled here, because the length is also changing, and it's said that it's made half its original length. So this will get cancelled and the x value would be root 2. So the correct option for this would be option number 4, that's root 2. Let's go into question number 49. It's about gravitation, and again it's not a very difficult question. It's a medium level, we can say. The minimum energy required to launch a satellite of mass m from the surface of the earth of mass m and radius r in a circular orbit at an altitude of 2r from the surface of the earth is. Now the concept that you require here is that on the surface of the earth, the satellite will actually have potential energy, and the potential energy is given as minus gmm divided by r, where r is the radius of the earth, m is the mass of the satellite, capital M is the mass of the earth. Now if we talk about at a higher altitude of 2r from the center of the earth, not from the center of the surface of the earth, that means from the center of the earth the distance will be 3r, but at this point of time it will have both kinetic energy and potential energy at that height. That means it will be the relation for total energy. So the total energy would be nothing but minus gmm divided by 2 times the distance from the center, so we'll basically have minus gmm divided by 6r. So that's the total energy. So if you now want to find out what is the energy required, you have to subtract the final energy from the initial energy. So final energy was the total energy, which was this. Initial energy was minus gmm by r. So we can do that and do the calculations, do the maths. Minus, so it will be minus, so it will be plus here. It will be 5 gmm by 6r. So the correct option would be option number 3. So you have to do your calculation carefully. Remember what would be the total energy and what would be the potential energy. Question number 50 being the last question of physics. Let's just have a look. It talks about Lenz's law. A sheet is placed in a horizontal surface in front of a strong magnetic pole. A force is needed to. Now let's just look into the option and try to see which would be the right answer. Hold the sheet there if it is magnetic. Okay, if it is magnetic, that's true. Okay, there would be a force required which will hold. Now in case it is magnetic, hold the sheet there if it is non-magnetic. So in case if it is not magnetic, it won't be able to hold that sheet, because it is basically in front of a horizontal surface of strong magnetic pole. Now move the sheet away from the pole with uniform velocity if it is conducting. Okay, so what happens is that this is actually a metal sheet which is placed in front of a strong magnetic field. Now due to the properties of a metal, if it is magnetic in nature, the pole will basically have an pole will be induced. Okay, so we are talking about induction here. Now due to this, the metal will be pulled by the magnet towards itself, so a force will be required to keep the magnet in place. So that's very important. That's why the first option is correct. Now if the metal is non-magnetic, there will be no effect on the metal due to the magnet. Okay, hence there is no force required. Now whether the metal sheet is magnetic or non-magnetic, what happens is if we move it towards or away, the laws of electromagnetic induction says that there will be a change in flux which will be associated with this metal sheet due to the magnetic pole. This will result in a magnetic flux and there will be a current induced in the metal sheet. Now according to Lenz's law, this will actually try to reduce the cause. It will be such that the magnetic field formed due to that current will oppose the change in flux, so a force will be required. So if you move it away or if you move it towards, in both the cases there will be a force required. So the correct option for this would be A, C and D. With this we come to the end of this physics part from question number 26 to 50. Thank you.